Right, we will start with the first problem. First one, if A and B are real numbers, A and B are real numbers such that A square plus B square equivalent to 9, find the maximum value of 3A plus 4B. So, how to solve this question? By using the concept of Cauchy-Schwarz inequality. What is that inequality? 3 square plus 4 square into A square plus B square. It is always greater than or equivalent to 3A plus 4B whole square. So 3 square plus 4 square, it is nothing but 25. A square plus B square, it is nothing but 9. Greater than or equivalent to 3A plus 4B whole square. Square, if it goes, it will become 5 into 3. 5 square is 25, 3 square is 9. Greater than or equivalent to 3A plus 4B. So 3A plus 4B, it is less than or equivalent to 15. Less than or equivalent to 15. When I say less than or equivalent to 15, that means I will get the maximum value as 15. Maximum value for this question is nothing but 15. Very, very easy question if you understand the Cauchy-Schwarz inequality. 3 square plus 4 square into A square plus B square is always greater than or equivalent to 3A plus 4B whole square. Very easy question. It is a pure application of you knowing how to determine the maxima and minima using Cauchy-Schwarz inequality. Now, next question. These for the three real numbers. If A, B, C are three real numbers, A square plus B square plus C square. Let us use this concept. 3 square plus 4 square plus 5 square into A square plus B square plus C square. It is greater than or equivalent to 3A plus 4B plus 5C whole square. 3A plus 4B plus 5C whole square. These nothing but 25 plus 25, 50 into these nothing but 9. Greater than or equivalent to 3A plus 4B plus 5C whole square. So these nothing but 3A plus 4B plus 5C less than or equivalent to square root of 50 into 9. 50 into 9 less than or equivalent to 25 into 9 into 2. Root of 25 is 5. Root of 9 is 3. Again it is root 2. 5 into 3 into root 2. So the maximum value of this expression will be 15 root 2. Maximum value of this expression will be 15 root 2. This is the concept that I am using. 3 square plus 4 square plus 5 square into A square plus B square plus C square. It is always greater than or equivalent to 3A plus 4B plus 5C whole square. Very famous Cauchy-Schwarz inequality. Second problem, I hope it is clear. Third one, if x and y are positive real numbers, find the maximum value of 3x plus 4y whole square divided by x square plus y square. So this can be written as 3 square plus 4 square into x square plus y square greater than or equivalent to 3x plus 4y whole square. 3x plus 4y whole square. These are nothing but 25. 25 greater than or equivalent to 3x plus 4y whole square divided by x square plus y square. So if I reverse it, 3x plus 4y whole square divided by x square plus y square, it is less than or equivalent to 25. Less than or equivalent to means I will always get the maximum value. So the maximum value for this question is nothing but 25. Three problems are based on Cauchy-Schwarz inequality. 3 square plus 4 square into x square plus y square. It is always greater than or equivalent to 3x plus 4y whole square. Idea clear? Next one, find the minimum value of root of x square plus y square. If 5x plus 12y equivalent to 60. Again, we will use Cauchy-Schwarz inequality. 5 square plus 12 square into x square plus y square. It is always greater than or equivalent to 5x plus 12y whole square. 5x plus 12y whole square. From these easily you will get the answer. 5 square plus 12 square. 25 plus 144. 169. into x square plus y square, it is greater than or equivalent to 60 square. 60 square. So I want the square root of x square plus y square. X square plus y square, it is greater than or equivalent to 60 square by 169 is 13 square. So if I apply under root, it is nothing but greater than or equivalent to 60 by 13. So what is the minimum value for this expression? Minimum value for this expression is nothing but 60 by 13. I hope the idea it is clear. All are based on Cauchy-Schwarz inequality. Next question. This question is a word-based problem. First, we will convert each and every sentence into a mathematical expressions and we will solve it. Yash has just drawn 6 rectangles. Each rectangle will have a length as well as the breadth. So, length, let me call it as L1 for first rectangle, B1 for first rectangle. L1 is the length of the rectangle, B1 is the breadth of the rectangle. A1 is nothing but L1 into B1. A2 is nothing but L2 into B2. Like that 6 rectangles are there. It is nothing but L6 and B6. Yash has just drawn 6 rectangles. Each rectangle has a different length and width. L1, B1, L2, B2, L3, B3, L6, B6. Sum of the squares of the lengths is 40. Sum of the squares of the lengths. L1 square plus L2 square. Sixth rectangle length is L6 square. It is nothing but 40. Sum of the squares of the width is 20. B1 square plus B2 square and so on up to B6 square. It is nothing but 20. What is the largest possible value of the sum of the areas of these triangles? Again, we will use Cauchy-Schwarz inequality. L1 square plus L2 square and so on up to L6 square into B1 square, B2 square and so on up to B6 square greater than or equivalent to L1 B1. It is nothing but A1 square, L2 B2, A2 square, L6 B6, A6 square. I hope the idea it is clear. Right. This value is given as 40. This value is given as 20 greater than or equivalent to A1 square and so on up to A6 square whole square. These also whole square. So answer is nothing but root of 800, which is root of 160 into 5. Answer is 40 root 5. Answer is 40 root 5. Again, a beautiful application of Cauchy-Schwarz inequality. If a, b, x, y are real numbers, a square plus b square into x square plus y square is always greater than or equivalent to ax plus by whole square. I hope the idea it is clear. What is the largest possible value of the sum of the areas of these, sum of the squares of the L1, B1, sum of the areas. So these are nothing but A1, A2 and so on up to A6. I made a mistake. Instead of writing whole square, I wrote it as A1 square. So L1, B1 is A1, L2, B2 is A2, L6, B6 is A6, A1 plus A2 and so on up to A6. Now let me erase these whole square. I hope the idea it is clear. Next question. Suppose that A, B, C, D are positive real numbers. Find the minimum value of root of A plus B plus C plus D divided by root A plus root B plus root C plus root D. Let me use Cauchy inequality. 1 square plus 1 square into 1 square plus 1 square into, let me take it as root A whole square. It is root B whole square. It is root C whole square. It is root D whole square. Greater than or equivalent to 1 into root A is root A plus root B plus root C plus root D whole square. These are nothing but 4. 4 into A plus B plus C plus D. A plus B plus C plus D greater than or equivalent to root of root A plus root B plus root C plus root D whole square. whole square. Till here it is clear, right? So these are nothing but 4 is greater than or equivalent to root a plus root b plus root c plus root d whole square divided by a plus b plus c plus d. A plus b plus c plus d. If I apply under root on both the sides, 2 is greater than or equivalent to 2 is greater than or equivalent to root a plus root b plus root c plus root d divided by under root of a plus b plus c plus d. So if I reverse it, I will get 1 by 2. I will get 1 by 2. Another way is, this is a symmetric function. D is a symmetric function. If A is replaced with B, B is replaced with C, C is replaced with D, D is replaced with A, the function does not changes. So put A equivalent to B equivalent to C equivalent to D. This will become root of 4A by root A plus root A plus root A plus root A. So these are nothing but 2 root A divided by 4 root A. These is nothing but 1 by 2. These are nothing but 1 by 2. I hope the idea it is clear. In a symmetric function, if A is replaced with B, B is replaced with C, C is replaced with D. If the question is not changing, then you can make A equivalent to B equivalent to C equivalent to D. That will give an answer. Top it is root of 4A and denominator it is 2 root A divided by 4 root A. Answer is 1 by 2. All are based on Cauchy-Schwarz inequality. A plus B plus C plus D equivalent to 1. You can solve this problem in 3 methods. Method 1. Method 1. Because it is a symmetric function, make A equivalent to B equivalent to C equivalent to D. 4A equivalent to 1. A is nothing but 1 by 4. These 1 by 16 into 4. 1 by 16 plus 1 by 16 plus 1 by 16 plus 1 by 16. Answer is nothing but 1 by 4 based on the symmetric function. Method number 2. Method number 2. 1 square plus 1 square plus 1 square plus 1 square into a square plus b square plus c square plus d square. It is greater than or equivalent to a plus b plus c plus d whole square. These are nothing but 4. These a square, it is a square plus b square plus c square plus d square greater than or equivalent to a plus b plus c plus d is 1. So answer is a square plus b square plus c square plus d square greater than or equivalent to 1 by 4. Cauchy-Schwarz inequality also you can use to get this answer. You can also use root mean square greater than or equivalent to arithmetic mean. That also will give an answer. A square plus b square plus c square plus d square divided by 4 greater than or equivalent to a plus b plus c plus d divided by 4 whole square. A plus b plus c plus d is 1. 1 by 16, 4 by 16, it is 1 by 4. 3 ways to solve. Root mean square greater than or equivalent to arithmetic mean, symmetric function property, or a Cauchy-Schwarz inequality. Next one. Given that a, b, c, d, e are real numbers, okay, a plus b plus c plus d, it is nothing but 8 minus e. Next one. A square plus b square plus c square plus d square. It is nothing but 16 minus e square. Find the maximum value for e. Now what we'll do is, we will use Cauchy-Schwarz inequality so that we'll get the answer in less time. Cauchy-Schwarz inequality. Let me use that Cauchy-Schwarz inequality. All the coefficients of a, b, c, d are 1. 1 square plus 1 square plus 1 square plus 1 square into a square plus b square plus c square plus d square greater than or equivalent to a plus b plus c plus d whole square. I hope till here. So these are nothing but 4. A square plus b square plus c square plus d square. It is nothing but 16 minus e square. greater than or equivalent to a plus b plus c plus d, which is 8 minus e whole square. These are nothing but 64 minus 4e square, greater than or equivalent to 64, 8 square is 64 minus 16e plus e square. 64 can be cancelled. These are nothing but 0 greater than or equivalent to minus 16e plus e square plus 4e square. These are nothing but 0 greater than or equivalent to 5e square minus 16e. So 5e square minus 16e less than or equivalent to 0. E, if I take a common, 5e minus 16 less than or equivalent to 0. Less than or equivalent to 0 means it always lies between the critical points. 0 less than or equivalent to e less than or equivalent to 16 by 5. 0 less than or equivalent to e less than or equivalent to 16 by 5. Easy question. A plus b plus c plus d is 8 minus e. A square plus b square plus c square plus d square is 16 minus e square. Then I used Cauchy's-Watts inequality. I got the answer very fast. 1 square plus 1 square plus 1 square into a square plus b square plus c square plus d square. I hope the idea it is clear. Variety of questions can be there based on a Cauchy's-Watts inequality. Next one. This is a very good question and it is a high frequency question. A polynomial has only 4 roots. 1 by 4, 4, 1 by 2, 2. If f of 1 equivalent to 1, f of 0 equivalent to how much? Let us first discuss the concept. Suppose if there is a quadratic function, f of x is ax square plus bx plus c. This can be written as a into x square minus of minus b by a x plus c by a. These are nothing but a into x square minus of alpha plus beta into x plus alpha beta. These are nothing but a into x minus alpha into x minus beta. That means any quadratic expression with 2 roots, alpha and beta, can be written as a into x minus alpha into x minus beta. If there are 3 roots are there, alpha, beta, gamma, this can be written as a into x minus alpha, x minus beta and x minus gamma. I hope this concept it is clear to you. This will help us in finding the value of a. If f of k some value it is given. Any quadratic expression can be written as a into x minus alpha, x minus beta. Now let us solve this question. A polynomial is there with a degree 4. So this can be written as f of x is a into x minus alpha, x minus beta, x minus gamma and x minus delta. Alpha, beta, gamma values are given in the question. So f of x is nothing but a into x minus 1 by 4, x minus 4, x minus 1 by 2 and x minus 2. Till here I hope it is clear. To get the value of a, we require the left hand side value. It is given that f of 1 is equivalent to 1. So 1 equivalent to a into 1 minus 1 by 4, 3 by 4, 1 minus 4 minus 3, 1 minus 1 by 2, 1 by 2, 1 minus 2. It is nothing but minus 1. So 1 equivalent to minus into minus plus. It is nothing but 9 by 8. A is nothing but 8 by 9. A is nothing but 8 by 9. Very, very good question based upon the remainder theorem corollary. If the roots of a polynomial expression are alpha, beta, gamma, then a polynomial expression can be written as a into x minus alpha, x minus beta, x minus gamma and x minus delta. Alpha, beta, gamma values are given in the question. Alpha, beta, gamma, the values are given in the question. I hope the idea it is clear. Next question, each and every question one model, right? Find the area of the region bounded by the graph mod x minus 7. Question is mod x minus 7 plus mod y minus 9 equivalent to 12. Mod x minus 7 plus mod y minus 9 equivalent to 12. Concept, suppose if the question is mod x plus mod y equivalent to 12, mod x plus mod y equivalent to 12, put y value 0. If y value, if it is 0, mod x equivalent to 12, that means x will be 12 or x will be minus 12. 12 comma 0 or it is minus 12 comma 0. Mod y equivalent to 2. If I put x equivalent to 0, mod y equivalent to 12, 0 comma 12 or 0 comma minus 12. 0 comma minus 12. This is the graph for mod x plus mod y equivalent to 12. Mod x plus mod y equivalent to 12. Suppose in front of you there is a water bottle. There is a water in it. It has got some volume. If I shift this water bottle from this place to this place, will the volume change? Will the area of this figure changes? Right? If I translate a figure or if I rotate a figure, or if I shift a figure from one point to another point, the area of the graph does not change. Please write down that point. Area of the graph is unaffected. Area of the graph is unaffected. Area of the graph is unaffected. If I shift the graph, or if I rotate the graph. If I shift the graph from one point to another point, or if I rotate the graph, area of the graph is unaffected. Not only area of the graph, number of integral points are also unaffected. Number of integral points are also unaffected. Number of integral points are also unaffected. Mod x minus 7 plus mod y minus 9 equivalent to 12. Actually, this is at a point 0 comma 0. It is shifted to 7 comma 9. Every point of x comma y is shifted from x dash y dash to x plus x dash y plus y dash. This is something which we discussed in our school days. Area of the graph is unaffected if I shift the graph from one point to another point, or if I rotate the graph from one point to another point. Area is unaffected, perimeter is unaffected, number of integral points are also unaffected. So the area of this graph is similar to this graph. Now if you see, it is a rhombus. This is nothing but length 12 units, width is also 12 units, 12 units and 12 units. This is nothing but x and y axis, so it is a right angle. Area of the right angle is half into base into height. Like that I got 1, 2, 3, 4. So into 4. This is nothing but 2 into 144. Answer for this question is 288 square units. Very important learning. Kindly make a note in your notebook. Area of the graph is unaffected, perimeter of the graph is unaffected, number of integral points are also unaffected. So total rhombus it is there. So 4 into half into 2 d1 into d2. So these are, it is length here, it is breadth. We will do a lot of sessions related to area in the next few workshops. I hope this question is clear.